Well, good evening, everybody, and welcome to this evening's meeting of the Astronomical Society of Edinburgh. I'll just say a few words in a moment about things to do with the Society. And tonight we have two talks, one by Robin Haig, the launch director of Skyrora, and that'll be followed by Alan, who will be talking about the sky in March. As usual, if you have any questions during the talks, if you're using Zoom, if you put them on the chat line, and Peter will call your name at the end and you can ask your question. If you're watching on YouTube, the live version tonight, and you want to put your questions on the chat line, on the comment box, we'll try and read out as many as we can get through. If you want to stay in touch with the ASE, you can do it in a variety of ways. Our website's the best place to go, where you'll find links to all our talks that we've done during lockdown, as long as a host of other information. Facebook page, Twitter, and our own YouTube channel our own channel on YouTube. Just quickly, we have a new video which Mark has made, which highlights the outreach program we have, 4 Steps to the Stars. There's a whole series of videos, pieces you can read on the website, right the way through from buying a telescope. We run some telescope help shops, which tend to be live events, and you'll need to watch out on our website or Facebook for those. Alan did an excellent Navigating the Night Sky talk, which is on our YouTube channel. And what started as going to be one imaging session turned into 5 imaging sessions, everything from just using a camera and a tripod right through to imaging for science. So if you're interested in any of that, please go and have a look. Also, if you're a member, you can join our very active imaging and observing group, who are busy collecting their own images of the Maser catalogue at the moment. And if you're interested in joining us, it's only £30 a year, but if you're a concession, half that. Terrific value for money. That's the end of the plug. I will move on. Just to highlight that we have coming up next Wednesday, the Imaging and Observing Group. Then Randall will be joining us for Comic Tales, a slight move from the normal technical approach to the subject of astronomy, looking at literature and astronomy. Bruce Vickery will be doing another historical talk on the Venus tablets of Amisaduga, followed by some scope talks, where a couple of members will be talking about their equipment. And on the 7th of May, we've got to Dr. Sam Lawyer talking about the Outer Solar System Origin Survey. And we've got Professor Catherine Haymans on the 20th of May talking about the dark side of the universe. So that's what's coming up. And the only other bit of news is our honorary president, Professor Andy Lawrence, who's just joined us, has just published his new book, Losing the Sky. Do you want to say anything about that, Andy?
Well, very briefly. It's slightly relevant to tonight's talk, but we'll see. It's about the problem of the pollution of the night sky by the new breed of mega constellations and the problems that they're causing for both casual stargazers, amateur astronomers and astrophotographers, and of course professional astronomy. So the book, so it's non-technical, so it's intended for, you can recommend it to your auntie, as it were. But it's also I hope people will enjoy it because it's a very personal take. So there's a lot of sort of personal descriptions of my experience, and so it's somewhat of a sort of poem to astronomy, as it were, as well as tackling and explaining this problem and what it is we can we can do about it. Yeah, anyway, so if you're interested in going, it's dead cheap. That's the best thing about it. It's extremely cheap.
I've read the book, Andy. It's extremely interesting and entertaining, well worth a read. So I can recommend it to everybody. Okay, thank you, Andy. So I'll hand over to Robin Haig, who's head of launch at Skyrora, and we'll hear about what happens in our local rocket company. I'm only about 5 miles down the road from, I think it's Lonehead you're at, Robin. So
yes, indeed. So we're not very far away.
Yeah, I'll stop sharing. And if I could just move this out of the way, that's it. And hand over to you.
I'm not sure that's popped up yet. There we go. Can you see that now?
It's just going yes. Yes.
Excellent. So yes, thank you for inviting me. I'm Robin Haig from Skyrora, and we're making some excellent progress that I'd like to tell you about. We're a small launch vehicle company, started in 2017 in Edinburgh, and we're headquartered on Princess Street. So in the times when you were down that way, you could have seen our office door, at least, the office is higher up, with a mock-up of the rocket that we're working towards, and from time to time one of the small test rockets in the window next to next. So it's something to look out for next time. Actually find yourself in the future in the city centre. So our particular opportunity, our particular market that we're looking for is small launch. There are a lot of satellites which are getting smaller and smaller, and there's still no really good way for them to get up. Starting to see, particularly Rocket Lab from New Zealand, which is the first company to actually properly enter the market in this sector. But otherwise, small satellites are looking to ride share, to hitch a lift on bigger missions, typically flying with Ariane or with SpaceX, in which case then you're beholden to the prime payload. There are plenty of occasions where small missions have been held up for significant lengths of time because the prime payload that they were hitching a lift with was held up with, and don't necessarily get to where you want to go. So it's not yet advancing. There we go. This is the vehicle that we are working towards, Skyrora XL, and we want to be able to provide the taxi service as opposed to the bus or truck of SpaceX. So it'll feel pretty big. It'll feel pretty big to be next to. It's 2.2 meters diameter, 24 meters long. It's still, though, it's still very small compared to vehicles like Falcon 9 and Starship that we're seeing developed. For those familiar with Princess Street, again, the top of this rocket would be somewhere like the supporting spikes around the Scott Monument. It's not actually as tall as the monument itself. So we're looking to put around 300 kilos up into a 500 kilometer sun-synchronous orbit. And we have a particular opportunity from Scotland in that we have a strong and growing small satellite construction sector in Glasgow. We've got an increasing satellite data handling sector in Edinburgh, and the recovering ground station in Dundee. What we're missing is launch, is the access to space, and that's what we hope to provide with Skyrora. Scotland is well placed for launch, and really, along with Norway and Iceland, are the only places that can seriously consider it from Europe. we are because we're a new starter, a blank sheet, as it were. We have set out to make our program as sustainable as possible from the beginning. We want to provide access to space with the minimal ecological cost. So the vehicle itself is designed for simplicity of manufacture, efficiency of materials, and reduction in space debris, and also something we'll come across later on in terms of the fuels that we're looking to use. Rather than jump straight to building the orbital vehicle, we are pursuing a step-by-step approach, and we have begun quite small. Now, some of the smaller vehicles have garnered quite a lot of publicity, really more than I expected. And it's important to point out that those small ones are testing subsystems. So we're putting vehicles together. This was the very first one, Skylark Nano, putting vehicles together using commercially available solid rocket motors, because it means that we can test systems in a launch and build up practice and just gain all sorts of advantages, whilst the primary program is developing the technology for the orbital vehicle. So I must say that some of you will have seen the press coverage really sort of treating some of these small launches like they're an orbital launch, which is not, but they are a tremendously useful process, and it really it helps us step forward quicker by doing these small individual launches. So this is a photograph from its first launch in 2018, and we'll have some. I think I think the main computer has dropped off. Hopefully it'll be back on again in a moment. I would explain that I've got the camera by phone, but the presentation on a different computer. And that computer is telling me that it is dropped offline.
That's fine, Robin. We can be patient. It's fine.
So Zoom is continuing to. It's quite handy having this second portal onto it. Zoom is continuing to tell me that it's not connected. I'll just try turning it off and on again. There we go. That's looking promising. Let's see if we.
You don't do that with the boosters, do you?
Not as yet. I think it's dropped off the share.
I saw a thing, speaking about boosters, I saw a thing on SpaceX where the rocket exploded 8 minutes after or returning to ground.
Quite spectacular.
It was exactly that was what I think. I didn't realize it was so long afterwards. It obviously lucky. I don't know what they.
I really thought they would. I thought they would make progress. I thought they would get closer. I thought they would soft land it and it would fall over, but not that they would soft land it and then have it blow up again somewhat later.
Yeah, eight minutes later, they must have been having saying, "Oh yeah, we've got this is really good," you know. And then 8 minutes later, something happened.
It did look a bit buckled. There we go. This should be this computer back again. Okay, so and at any moment we'll return to the presentation.
looking good.
Oh, now, of course, it's showing us the. Oh, there we go. Let's come up to. All right, now where were we? So this is now some nice footage from that particular launch.
Where is it?
So I can see the starting slide, and now it's refusing to play, which it didn't do when everything was prepared earlier.
Robin, are you just going to make your way back to where you were?
Yep, it's on my second view. Actually, it's still not showing up to date to what I've got on. It's like a slide behind, which is quite curious. So any moment now, you should currently be seeing, I think, the nano launch, and then we should step over. Okay, we'll move on from that. I don't know why it's failing to play. So the next vehicle up. So nano has proved useful for a number of small tests, and has enabled us to test a variety of electronics and things. But then the next vehicle up in our sequence is Skylark Micro, which is a two-stage vehicle. So nano, we're only looking around 6 kilometers. It's quite small. It's not getting very high. But with micro, then we're pushing on to 30 kilometers or 100,000 feet. So we're still using commercial off-the-shelf propulsion, and putting that together to reach a more significant altitude, again with electronics. Now, for this particular vehicle, we had the opportunity to explore launch from Iceland, and we can now. I can see on my phone that the slide has successfully arrived. We can see micro on its launch rail, set up at about 10 degrees. We really want to make sure it biases offshore. And on the right-hand side of the screen, we can see Iceland and the Langanas Peninsula and Sordanes, or Sordanas up in the top right, which is the location that we were at for this flight. And it was a tremendous experience. It went very well, and we were able to collect data from a significant altitude. Again, it's steps forwards for us. Now we will see if the next section can be the next video can be persuaded to play. There's the rocket at takeoff. Within this, you can see, yeah, the mouse is working. We have the first stage here, first orange fins up to the aluminium transition, and then second stage, of course, above that. It's 100 millimeters diameter at the base and 75 millimeters in the top. A big push to get it shifting, and then a long burning low thrust mode to really pick up the altitude. I'm not sure whether this is something to do with the settings. Have
I think Zoom
successfully used video on Zoom many a time before. Had hoped to be able to show you the launch footage of Micro taking off. Maybe we can see about revisiting these later on.
The playing videos is
So
definitely low.
useful and useful and fun as the small vehicles are towards building towards the larger program. Of course, they are not themselves the main technology which we're working towards. So in parallel to doing the small test flights, the telemetry and test and tracking with the small vehicles, we have been working across the board on the systems that we require for the larger vehicles. Propulsion tracking, flight termination testing, and we're in line with many companies in our sector. We're pursuing 3D printing for the engines, and we can see a number of shots here of engines being built up. There's various different techniques. Our initial ones started off with powder bed deposition. We're now looking at spray deposition, and these are tremendous advantage for rocket engines, because you can dramatically reduce the number of parts. Of course, with bi-liquid rocket engines, you have internal cooling channels, and you can create them as part of the part itself. So it really improves the whole product. Cuts down the number of parts, cut down the weight. You can get closer to the ideal shape, because with 3D printing, more or less any shape is as easy as any other shape. One of the challenges with the powder bed systems, of course, then is that you end up with your cooling channels full of powder. So then there's the challenge of getting them empty again, getting them clear, and making sure that the flow path is good. But we've had quite some success with it. And also in pursuit of the sustainability of the launch program, the clean slate sustainable access to space, we also have a program to create a kerosene equivalent, a rocket grade kerosene equivalent from non-recyclable plastics. So it has succeeded in producing a usable fuel, and we have tested that already in the engines. So we're hoping that will be ready for flight around the time that the vehicles themselves are. And of course, in terms of non-recyclable plastics, it is still a fossil source, but by being able to turn it into a fuel in this sense, we're making it a lesser problem. We're taking away the greater problem of the plastics, because it's all the worst things like expanded polystyrene, and that's the kind of stuff that we can use in this. And over kerosene itself, it's cleaner because it doesn't have the sulfur content, because that hasn't been in the plastics. So it's on two fronts. We're removing this waste problem and displacing kerosene, displacing mineral kerosene that would be in itself more polluting than the eco-C, the plastic derived fuel. So we have been currently working on two streams of engines, and we have a third one coming up soon. On the right of the screen here, we've got Leo, which is our upper stage engine. This was the very first testing at Spaceport Newquay in Cornwall, in a hardened aircraft shelter which Bloodhound had been using for their engine testing. We can't fly from Spaceport Newquay because we need a vertical spaceport. They're a horizontal spaceport, but they're tremendously enthusiastic, so it was really nice to be able to do something with them. Early in our program, when we didn't have our own test site, we were able to take the containerized. You can see it's all incorporated into a container, a containerized system down to Newquay for that first test. Now, currently, we have that one is qualified. That's done, and we have also completed the test program on the engine on the left, which is the 3-ton engine, which is taking us towards our first space vehicle. another video which is failing to run. We can see here the third stage engine setup later in its engine test program on the stand. And that engine is going into this vehicle. So this is Skylark L, 11 meters tall, 750 millimeters diameter. And this then is our first full space vehicle. It's single stage, it's pressure fed, suborbital, so it can take about 30 kilos up past 100 kilometers and then recover again by parachute. And the purpose of this particular vehicle for ourselves internally is as the complete test bed of all the technology then that's going into the orbital vehicle itself. Looking along the vehicle, in the different color sections, the black parts are the tanks and the carbon fiber overwrapped tanks. We have helium for pressurization at the top, peroxide in the middle, and kerosene, which actually is a good point to bring up. Our propellant combination is hydrogen peroxide and kerosene, which is somewhat unusual these days, but was a UK specialty in the past. And it has been a neglected combination because compared to liquid oxygen, hydrogen peroxide system will have a slightly reduced performance. However, it does lots of other good things for us. And partly you can see with this particular vehicle in how small the kerosene tank is. It's just this little bit at the bottom. Hydrogen peroxide is H2O2. It's water plus an extra oxygen. And it burns in very high mixture ratios. The peak of peroxide propulsion so far is Black Arrow, the UK's only satellite launch vehicle, which we were involved in recovering the surviving first stage from Australia a couple of years ago, which is now at the Farnborough Air Sciences Trust Museum, Farnborough having been the design authority, the Royal Aircraft Establishment for Black Arrow. Black Arrow burnt from, the combination in 8-to-1. If you see a cross section through Black Arrow, it's almost all peroxide tank with these tiny little kerosene tanks. And peroxide is very dense. It's 35% denser than liquid oxygen. It's 1,400 kilos per cubic meter. And so what this all does is leads to a compact, dense, simple vehicle that is biased towards your biggest propellants, because peroxide is also bringing extra energy in the extra oxygen link onto the water. Because then what it can do for us is if you force hydrogen peroxide to a stack of silver-coated mesh as a catalyst pack, it spontaneously falls apart into 600-degree steam and oxygen, free oxygen. And what that does, as was done on Black Arrow, is you can incorporate a catalyst into the top of your rocket engine. And that means all you have to do, obviously it's a little bit more sophisticated, but in principle, all you have to do to light your biliquid rocket engine is to open the valves, because the temperature of the hydrogen peroxide is such that when you add the kerosene, it will also ignite. And the mixing is very good as well, because your oxidizer is coming in as 600-degree hot gas. Because it's water plus, it's really good coolant, so you can cool the engines with it. You've got masses of coolant available. And then you can also run the turbo-pumps as a steam turbine purely on decomposing hydrogen peroxide, which again is something that Black Arrow did. So as well as being a compact, simple vehicle, ambient, no cryogens, no low temperatures to deal with, always easier. It also makes for a well-mixed, efficient, lowly, relatively, rocket engines. For a rocket engine, a lowly stressed vehicle with a comparatively easy power turbo pump. So it ticks off the two big problems in creating biliquid rocket propulsion: the turbo pump and the injectors. So this vehicle has been ground tested last summer in the Highlands, and it was the first ground test of a biliquid rocket engine, a biliquid space vehicle, sorry, since the last Black Arrow was ground tested on the Isle of Wight in 1971. Such was the challenges of last summer. The original original test site that was going to be available was not available, and we had to put together a new one, a mobile one in the Highlands. And although this video is going to refuse to run as well, you can see how tremendously low impact the system is. We have a transporter erector here, which is serving as the launch pad. We have an oxidizer control system in the 40-foot container. We have a kerosene controller in the 30-foot container, compressed gas in the blue container, and portable generator. And this is essentially everything that we need for launch of this vehicle. Then for this test site, a new steel bridge, which it is sitting on, it was put together and ballasted down. The thrust in this engine is only 3 tons, so there was no chance of it going anywhere. But we did have to reassure the CEO that it was well ballasted and bolted and strapped, and it definitely wasn't going to move. But it was a very successful test, and this vehicle is essentially ready now for flight. Which brings us to our most recent coverage. We had a bit of coverage in January, not quite as much as we have done previously, seeing as that there is no quiet news day currently. But we have moved on to the all-up ground test of our 3rd stage. So looking at the cross-section through Excel to the orbital vehicle at the bottom, you can see the 3rd stage on the left-hand side inside the fairing. So it's going to be completely hidden in in the nose cone, whereas the 1st and 2nd stages make up the cylindrical outer diameter of the rocket. And this uses the LEO engine that we had previously showed testing at Spaceport Newquay. We've been through an extensive ground test program, including with gas dynamic tube for vacuum engine testing, and now has been incorporated into this stage. So this is the first part of our orbital vehicle, and it is fully flight weight and has now completed its test. As you can see, we have a fondness for containers. We have set out to make our launch system anyway as mobile and flexible and modular as possible. Our great inspiration for this is SpaceX Falcon 1 launch in the South Pacific before anyone let them launch from America. And because commonly the new potential spaceports generally show Mahia in New Zealand as an example, which is an excellent example, and I think it's just the sort of thing that we will see in Scotland building up. But the Falcon 1 Omelette launch is even more minimal and shows just how low impact in terms of getting us to launch sooner and in terms of minimizing environmental footprint. So for our 3rd stage test, which we only need to do once, we're able to create this portable test stand and building upon containers. So you can see the 3rd stage mounted up there, and again we'll try and come back to the videos and see if I can run them directly in VLC or something outside of within Zoom, but outside of PowerPoint. We can see the system running there from one of the CCTVs up in the container, looking down through the combustion port. So this was a full duration test. The 3rd stage. The reason we have the 3rd stage there is it gives us more flexibility. A lot of satellite launch vehicles now tend to be 2 stages. It's the minimum that you can do with. But because our peroxide engines are conveniently restartable because of that catalytic ignition, no sparks, no nasty ignition chemicals needed, we can very easily restart in orbit. So the 3rd stage gives us the flexibility to put different payloads. Even as a small launch vehicle, we could still be launching clusters. It gives us the ability to put different payloads into different orbits, put one in one place, boost on higher to a different place, so people can get to really where they want to go. And with this, we have the opportunity within Scotland to provide the entire space mission ecosystem. You can buy your satellite in Glasgow, launch it from the north, somewhere in the north with us, and then handle the data reception and analysis with Dundee and Edinburgh. So with this test, which we were fortunately able to do before the situation with the restrictions had to be tightened, it ran for the full burn time, 3 ignitions, 450 seconds, just like you see of the SpaceX second stage when they revisit the webcast, and with the wait time as well, which was quite frustrating. So it's got 30 minutes between burns, and we had to have the big long burn and then wait another 30 minutes for the as if it was circularizing the orbit. But it was a tremendous test, and it worked really well. Of course, one of the questions at the moment is where launch will be from. There are 3 sites that are interested in becoming vertical launch sites in Scotland, and they all have their own advantages. We are friends and cooperating with all 3. Indeed, all 3 could find a job. It may drop down to 1. There may be 2 of them, but we're keen to see anyone who would like to in this area succeed, and we want to help all the spaceports get there. So this is example directions from we'll go left to right from the Hebrides, from Spaceport 1, from Sutherland, from Spaceport Sutherland, and from Shetland Space Centre at Unst at the northern tip of Shetland. And they really do all offer slightly different things. So we're optimistic that we will see the opportunity to fly from one of these sites soon, and we're working towards that. So we feel that we are now in a strong space. So we have the headquarters, Princes Street, and we have a workshop facility in Loanhead, and we're continuing to expand. We have a growing team, and we're working on many different aspects at the moment with the enhanced engine testing for XL, working on different opportunities for where we may launch this vehicle, and significantly, unfortunately, but significantly, of course, a big part of it is paperwork, because we are blazing the trail currently. We believe we will be first to fly privately from the UK, and so we're the first ones going through the paperwork process. So that's a big job in itself. We're getting tremendous interest in launch letters of intent, of course, people interested in launching with our system, and a lot of interest actually in Skylark L, in the suborbital vehicle, which we had created for our own internal development, but we believe we may well be able to bring the same cost and convenience to suborbital scientific launching that we're aiming to bring to orbital launching. So the looks like L may well become a product line in its own right, which would be tremendous news. So that's a sort of whirlwind overview. And do you typically do questions?
Yes, if you don't mind, Robin. Peter, have we got any questions?
I saw I couldn't see what was happening in the chat, but I thought
Sorry?
Sorry, you call them out, Peter.
Yeah, we have some questions.
I will also, in the meantime, I'll see if I can. I'll get the videos in VLC, and then we can see if we can play those as well.
Okay.
Well, thanks very much for that, Robin. It's very interesting, and it'd be nice to see the videos running if we can.
That's always the fun bit. That's what we want to have.
The first question was from Dave Craig. Dave, are you there to ask your question? Unmute.
Yep. Okay, here we are. Yes. Thanks, Robin. I was watching some V2s launching, and they all wiggled like mad at the beginning and crashed.
Oh,
and it
yeah.
struck me that you have to do something at the bottom of Skylark L, but I can't see how you do it, and it does sound quite challenging to to make that work?
In terms of sort of steering and guidance.
Yes, how you steer the
thinking?
rockets, the rocket exhaust because it's so
Yes.
hot, and how you do the
So-
gyroscope bits to make sure it actually is pointing the right way.
Yes, so we've got tremendous advantages now starting with the gyroscopes, building out of. I think they started with missile technology in the 90s, but now widespread across phones is solid state gyroscopic technology, inertial measurement system, or inertial measurement device, which are sort of remarkable etched silicon inertial sensors, which are used in rocket guidance now. So we don't have to have the moving parts of traditional gyroscopes, which is very good. And then with L and leading on to XL, we gimbal the entire engine. The whole thing moves around. And as Black Arrow did, with Black Arrow had 8 engines, and so they actually treated it rather more like elevons and rudders with pairs of engine moving around the space in the middle, and that's what we can do with XL as well, which makes it a little bit easier. We don't have to have the full gimbaling. We can use we have 9. So one of the things that Black Arrow did that was very nice, which we can't do, is Black Arrow's launch clamp was like a tow bar in the center of the rocket. That's to hold the whole rocket down by this single steel ball in the center. So it's all perfectly symmetrical. So we've got an engine in a way. We can't do that. But that always struck me as a very nice feature of Black Arrow, was how they did that. And you can see it on the Black Knight in Edinburgh Museum.
Okay, thank you for that. Neil, I think you were next on the list about major players.
Yes, thanks, Peter. Thanks very much, Robin. Thoroughly enjoyed that, and great to see that all this is happening right on our doorstep. My question was, are any of the major players that you mentioned interested in developing smaller vehicle launch capability? Is that an option of interest for them, or do you see yourselves remaining alone in that niche?
Well, it's quite there's a lot of people interested in it. The original incumbents haven't, and Falcon 1 that SpaceX started off with, I think, was capable of lifting just under a ton, and they actually concluded it was too small. Although they did have the advantage that after they launched Falcon 1, they got the contract for Falcon 9 and space agency space station supply. So that certainly helped push them onto that. But there's a lot of companies which are interested in making small launch vehicles. I think the last time I saw it's maybe around 120 across the world. None of the incumbents are doing it. I think ESA's Ariane's Vega is the smallest one, which I think is around 1,200 kilos or something like that in the original launch providers. But then for small launch vehicles, Virgin, of course, had a great success with their first launch off California, their American system. Rocket Labs are up and running from New Zealand. They're the first people to really get going in the sector. But then there are plenty of others, and of course, as was recently covered, Lockheed are interested in bringing one of their companies they have an investment in, ABSL, over to a launch, with their interest in Shetland in that case. So it's a fascinating sector. There's lots of different companies working towards it. It's rather like aviation in the 20s. It's space launch in the 20s.
Thank you.
Andy, you're next on the list, please.
Hi, so, thanks very much for that, Robin. I was wondering, have you tried testing actually carrying a payload and releasing it yet, or is it too early for that?
No, so far everything has remained connected. We'll just see if I see VLC showing. I'll just click play and see if it goes. So this is on board Nano 1 in summer of 2018, and we say we're going up to 6 kilometers in about 30 seconds. I'm seeing on my phone, I'm seeing the video is a little bit jumpy, but at least we're getting to see the process of it. And then at apogee, which we have just reached, it pops into two halves but remains joined. So it tumbles. It's typical HPR, typical rocketry for this type of stuff, this type of off-the-shelf propulsion. It tumbles most of the way down, tied together so that it makes sure it's not going to drift a long way with the parachute, but still doesn't come back like a missile. You know, it tumbles benignly at a reasonable terminal velocity, and then just near the ground, it pops out its parachute and makes a soft landing. So this is the same approach which we have done also with the larger vehicles so far with micro and other nanos. In terms of SKL, it's going to set off again. Just stop that one. In terms of SKL, the suborbital vehicle, it will remain in one piece, and it will then deploy a parachute and flotation from the space around the top of the nose cone. So even the big one actually will still be coming down as one. But of course, once we get to XL, once we get to the orbits, then we'll be getting on to separating them.
Okay, thank you. John Morrell?
Hi, yes, hi, good evening, Robin. Thanks for the presentation. Just a question about where the name Skylark came from. Is there any relation to the original UK Skylark, obviously that was very successful?
Inspired by it.
Oh, okay.
Yes, so, sorry, I'm trying to do too many things at once there. Yes, it's we don't have a design connection to it, but we were inspired to use the name because of the similarity with Sky,
yes,
Skyrora, and because it is an inspiration as the UK's most significant, most significant space launch vehicle. I think it's over 440 of them launched between 57 and the
so
early
the
2000s.
Skylark launch panel over my shoulder isn't much good to you then? Sorry, over that side.
Oh, that's marvelous.
That's in the science
Sorry,
museum in
I
London.
see. I hadn't spotted you have parts of those systems there. Right.
Yeah, that's in the Science Museum in London. There is or was in the end of 2019 a display, a part of their rocket display, and they've got the Skylark there and various other things. And of course, that had a big impact on some of these UK scientists who worked on it.
I heard from a number of people that there was a time when you could design an experiment for your PhD and get it flown to space.
Yeah, well, John Tarlicki is one of them, of course. And actually, his PhD is actually in that display. I don't know what that makes him feel like, but you see your PhD in the museum, I suppose it says something about your career. Thank you, anyway.
Thanks for that. Fran,
with any
you
luck,
got a question?
Yeah, it's Nigel. She's only got her name up. Yeah, it's just thanks very much, Robin, for a fantastic presentation. Very enjoyable. Many of us have been watching the further adventures of SpaceX, and it struck me that all the development that you're doing must cost a very large amount of money. When would you expect to be coming into profit as a company? And also, how did the company start? Was it a conversation in a pub, or how did it actually come into being?
Well, it was started originally by the first chief operating officer and Daniel Smith, who's now elsewhere, and the CEO Vladimir Levikin, both based in Edinburgh, who saw how SpaceX and Blue Origin, both IT-related businesses, or growing out of IT-related business. So, you know, SpaceX has always been launch, but Musk made the money in the internet, getting into space and the potential of satellites. And they had been previously in web services and were interested in this opportunity. So they saw the chance, given the renewed focus on space in the UK, which started around 2008, something like that, and then the ambition stated around 2010 to capture the market and a certain percentage of the market by 2030, and to have launch from Scotland. They felt that this was an inspirational and unique opportunity to establish an Edinburgh, a Scottish launch provider. Oh yes, and we expect ultimately to be in a position to fly sort of 12 to 16 vehicles a year, and by the time we're getting up to about sort of 5 vehicles a year, then things are settling down.
Right. Good. Thank you.
Good.
We should have the micro launch here with any luck.
All right, let's see that now.
So this is the old Sordanes runway in northeast Iceland. We see a little bit of a shimmy going on because it's a very long, thin minimum diameter rocket, but it's tracked very straight and disappeared nicely into the cloud, and on its way to sort of 26-30 kilometers.
Okay, Dave Craig has a question. Are you there, Dave?
Yes, I'm back again. Sorry, like a bad penny. I was thinking, when Skylark L comes back down in its parachute and lands in the sea, what happens then? Do you go and retrieve it, and do you do anything with it, or what?
Yes, certainly. So it most definitely will be retrieved. It will be buoyant. So acknowledging, of course, that marine recovery is going to be a whole other challenge once we finally come to doing it in practice. But that's the plan. It'll make a soft parachute landing and then be collected from the sea. As to its reusability, once it's been exposed to salt water, we shall have to see how we go. Overall, the small launch vehicles are focusing initially on expendability for the orbital vehicles, because it is more challenging for a smaller vehicle. There's less spare mass there to put recovery systems in. But rocket labs are now looking at, they're working towards experimenting catching. I mean, this is in terms of their orbital vehicle Electron. They're looking at catching Electron when it's on its parachute. They have done one test where the first stage is parachuted into the sea, recovered it. I haven't heard them comment as to how it was after the salt water, but their plan, which as far as I know is using a system developed by Irvine GQ and Airborne Systems, to catch boosters on a parachute with a helicopter. So then you can set them down on dry land gently. So it's going to be fascinating to see what they do. I think certainly SpaceX will mean that all of us involved in launching will have to look towards reusability. And of course, it does bring advantages. So we shall see how we go. It's an evolving situation.
Yeah, thanks for that. In the interest of time, we've got 2 questions left, one from our esteemed president and one from the esteemed Andy Lawrence. So we'll have the president first.
Thank you very much. Really, one from my naivety, Robin, other than parting with money for the rocket launch to get a satellite in orbit, what permissions do you need to actually put a satellite into space in the UK?
In terms of the satellite operator themselves, they will need a space license for their satellite in orbit. which is something that all the I think it's all the signatories to the UN Outer Space Treaty. Those various governments have set up the thing where you must have a space license, and it's about ensuring responsible space use. So in the UK, that's under the 1986 Outer Space Act, and for a long time that was, of course, the only sort of space license that the UK did, because we did have satellite operators based here who would have a UK space license, and wherever they were launched, if you're a UK entity, you would have to have a UK space license. Now, with the development of launch vehicles and launch sites, there's going to be 2 further licenses, three further licenses: space license for launch vehicle, license for spaceport, and license for spaceport range, the system downrange.
Is that a license that the operator and the payload people get one-off, or is that per launch, per satellite?
I'm not certain how it ties in, how it would pan out with the satellites. It would make sense. It would seem to me that if you have a constellation, maybe not as big as the ones that are around now, but a sort of a normal constellation, that you would be able to license it as a group. Certainly in other countries that have the launch vehicle license in place, it is possible to get a sort of a type license whereby from this site, this vehicle is covered. But we'll see how it develops in the UK. It looks like it'll probably be something similar. I think the spaceports will have their license, and then we will have our launch vehicle license, I think, is how it'll pan out.
Thank you very much. If we could round off with Andy Lawrence, please.
Yeah, just to comment on that last bit first. Presumably, you have to get a spectral license as well.
Yes, yes, for the radios.
But presumably that's not your problem. You just require that that your clients come armed with the necessary certificates, as it were.
Yes, so there'd be the orbital one, their spectrum licensing, but then also at the moment, because the launch infrastructure is still evolving, we secure Ofcom licenses for our telemetry directly ourselves.
Oh, very good. So I'm cheating because that wasn't really my question. So I think everybody's going to expect me to ask about satellite pollution, but I'm not going to, because it's clear that and someone like you has not got a role in that. You're not launching that many, and they're not very big. So, but
well, our third stage actually is also intended to be used as a space tug for removing dead payloads. And
that's what I was coming to was although you're not a sky pollution, a light pollution problem, as it were, everybody's got a role in the problem of debris. So you mentioned that very briefly, and you're only a part of the whole global industry, of course. But what do you think are the key things to stop us heading towards the Kessler syndrome?
Well, all the major launch vehicles now ensure that the stage that goes orbital comes down, is brought down, which is something we'll be doing with our scheme. The first and second stage or will be suborbital anyway, and the third is the one that's in orbit, but then it's conveniently relightable to bring it down. But then we have this opportunity to be able to use it as a system. We could actually, our third stage could be launched on other vehicles, or we could launch an additional third stage in parallel with a small payload to be then the space tug. Because I think the key thing is to really start to bring down anything that, all the low-hanging fruit, things like is it NVSat, the huge European environmental satellite, didn't last very long. I think it's a few tons. I think we can focus on the more specific things to start off with, to at least start
Do you mean you could actually have a business in
making it less busy?
Other people's junk? Is that what you meant?
There are people, there are companies which are interested in doing that, and a couple of them UK based as well, I think. So we could provide them with the propulsion to be able to do that.
That's cool, but my understanding is that there's big legal problems in that at the moment, because the Outer Space Treaty says that everybody owns their own satellites, and you
I see.
can't
Right.
treat other people as junk and go and grab them. I think, but maybe that could change.
No space salvage yet.
No, not yet.
Okay, thank you.
So we play this. It looks like this video will run of the engine test.
Super.
To summarize, and again, I'm not sure why we're not getting the sound. You'd think a year into video conferencing that everything would be smoother than it continues to be. It feels like every time I speak to another company, there's another different application to download. But, at least Zoom is a bit more familiar. There we go. So that was the engine test.
Okay, can I hand over to Will at this point and see if there's any YouTube questions?
Good evening, Robin. Yeah, it was a fantastic talk. I'd just like to quickly slip a question in, if I may, before I get a couple of YouTube comments and questions. Regarding satellite size for the future, what would you see the minimum size? I mean, in theory, could they ever go down to 10 centimeters by 10 centimeters? I mean, how do you see things in the future? Because small payloads would be very, very good.
There certainly are already ones up that are that small. As far as I know, I think the more common nanosatellite size tends to be sort of 10 by 10 by 60.
Right.
I think the 10 by 10 is currently a little bit small, and spacecraft like that can be used for very quickly getting things up and testing stuff, but then they come down pretty quickly as well. So they're, as I understand it, they're less of a problem, because they're so small, they decay back into the atmosphere quite quickly. I know Alba in Glasgow have been looking at some very small payloads, and the name escapes me at the moment, but there are other people that are looking at the picosats that are like a Raspberry Pi Zero, which has been launched and can still do something useful, if only briefly. That it's certainly a balancing act, isn't it, between getting convenient space access and not filling it up too much.
Right. And
we've got time for probably got time just for a couple of questions, Will.
A couple of questions, okay. One from Gray Timedan. Seeing Rocket Lab's recent announcement, will Skyrora in the future aim to build a human-rated rocket?
It's not part of the plan currently, but who knows?
Okay, and then we've got a very good kudos comment here of saying that we've got Rosa San is saying how good it is to see the sustainability that you're aiming for all your rocket things here in Scotland, which is fantastic. And she asks about the eco scene, which sounds amazing. What products of combustion are produced by using eco scene? Is that what you described with the hydrogen peroxide kerosene biokerosene mix? Yes.
So it's predominant. So hydrogen peroxide burning with a fuel is a very efficient combustion and tends to be very clean. You can see with the historic pictures of Black Arrow where the rocket looks like it's levitating because the plume is predominantly CO2 and water. It's a bit like with the shuttle with the liquid oxygen, liquid hydrogen. it radiates strongly in infrared, but there's essentially no soot, no particulates in it, so it doesn't radiate very well in visible light. So we're mostly looking at CO2 and water vapor. But and yes, that's the majority of the output from it. So then it presents the opportunity to recover CO2 by other means.
Right. Excellent. And then finally, I did actually see you at the Edinburgh University Careers last year. Are you recruiting?
We are looking for people currently. The open opportunities are always up on the website, and we have quite active social media, so anything new coming up will go up on there as well. But yes, it is. We are looking to expand continually over the next few years. So if anyone is interested, do look at the website. The vacancies are real, kept up to date, and reviewed frequently.
Excellent. I could think of one or two in our society might be interested. Okay, thank you.
Thank you. Well, if members would like to thank Robin in a normal way, that was excellent. Thank you very much for presenting to us, Robin.
Thank you very much.
And overcoming the challenges. Well, after that excellent presentation, I'm going to hand over to Alan for the Sky in March.
Right, I'll try and share my screen. Now, can you see that?
Yes.
Good, right. Can you see my laser? Right, good.
Yes.
Okay, the Sky in March 2021. I'm going to start with the slide that you're used to seeing, the charts that appear in the Scotsman each month and also on our Society webpage. These are the charts for March, valid at these times. And you'll notice that the BST begins in March, summertime, believe it or not, is coming on the 28th of March, when we set our clocks forward an hour and we lose an hour in bed. By the end of the month, this chart is still valid for 22 hours BST. First thing to point out is that the plough is now getting towards the zenith, which is here, climbing up in the eastern sky at these times, around 22 hours in the middle of the month. And as it does so, on the opposite side of Polaris, Cassiopeia is swinging below the pole as a two-turn counterclockwise around Polaris, the pole star. In the towards the west to southwest, Orion is getting lower down by this late evening time. And meantime, Leo is reaching the meridian. I'll talk more about Leo later in the talk. And there's only one planet on show at this time, and that's Mars, which is quite close to the Pleiades just now, moving up between the Pleiades and Aldebaran into between the horns of Taurus. That's the data for the sun this month, taken from Dominic Ford's inthesky.org website, extremely useful resource. A reminder that these times are GMT up to 28th, and the last line here is BST. And it shows that the days are lengthening. In fact, they're lengthening at their fastest rate for this year as the sun moves northwards at its fastest rate for the year during March. Here are the moon's phases. Again, around March the 13th, a week each side of March 13 is when we have the moon not really troubling us in terms of moonlight, so we have the dark of the moon, and at the moment we're just near the moon is quite close to last quarter in the morning sky. Mark Phillips has produced a nice image of the sun. There are one or two being posted to our WhatsApp group. This was taken on February the 26th and shows the sunspot group heading around a limb Of course, we had a nice talk from the BAEA section director, solar section director, a few weeks ago about observing the sun. Refer back to that in our YouTube channel if you want. Andrew obtained this image of the moon on February the 21st and one of the full moon, allegedly the snow moon on February the 26th. As far as the planets, Dominic Ford's website has this graphic which depicts the entire sky stretched around east to west, with the sun currently about to swap over from on the left-hand side of the chart to the right-hand side of the chart as it moves along this arrow during the course of the month. This is what's taking it northwards in the sky. This is the ecliptic, the path that the sun takes during the course of the year. And you'll notice that quite a number of the planets are concentrated in our morning twilight. In fact, they're Mercury, Venus, and Jupiter, and to some extent Saturn. They're all rather hidden in the twilight. You may just catch Saturn at the end of the month. That's a picture of Saturn as it will appear. The rings are starting to close up now. They're tilted toward the north face, tilted towards the Earth, and they're only 10 arc seconds from thick at their narrowest part, 35 arc seconds wide from side to side. Saturn's magnitude is 0.7, but it's very low in the morning twilight, and well, it's a difficult object to spot. The only planet which is easy to see, not as bright as it was a few months ago, is Mars, which is in our evening sky. I mentioned this before, it's quite close to the Pleiades just now. Mercury, of these morning twilight objects, is at its furthest west of the sun on the 6th, tomorrow, but it's rising then only 37 minutes before the sun. So you're not going to see it from as far north as Edinburgh. Venus is reaching superior conjunction on the 27th, when it's on the far side of the sun. And as I said before, Jupiter and Saturn are emerging from the sun's far side. But it's going to be a month or two before we really get a good view of them in our pre-dawn twilight. Let's look at, do a quick tour of the sky, around the sky on March the 16th at 22 hours. But this tour, the stars are in these positions at these times during the course of the next few weeks. So by April the 16th, the stars will be in this position at 21 hours BST, although by then, on mid-April, there'll be quite a bit of twilight around. If you notice, you can see the Milky Way stretching up from the northern horizon, climbing up through Cassiopeia and Perseus, and arching over Mars in our western sky. The plough is up here, reaching the zenith. On most of these charts, which show the whole view of north, south, east, or west, the zenith is roughly where my cursor, my laser is there, right in the middle of the chart, near the top. The plough here, Cassiopeia down here, Deneb and Vega, the two northern stars of the summer triangle, have now passed their low point in the north, and they're beginning to climb up, and they'll be visible in the eastern sky before dawn. You can just see here the glow of M31, the nebula, the galaxy in Andromeda. There's also, between Cassiopeia and Perseus, the double cluster, and a couple of other clusters that were imaged recently by members. Nigel Goodman got this one of NGC 188, which is quite close to Polaris in the sky. It's also called Caldwell 1. I think Mark mentioned this last month. And Mark himself obtained this image of M103 near in Cassiopeia, a rather small group of relatively bright stars. Turn west. There you see the Milky Way arching over the western sky through Auriga. Reminder that there's several star clusters of interest in Auriga, roughly where my cursor is, and there is a feature on them on the ASE web pages. Taurus is now below Auriga. Orion's down here heading towards the western horizon. And Mars, as I say, near the Pleiades. We'll come back to that in a while. Sirius is now to the left of Orion. You remember when Orion rises in the eastern sky earlier in the winter, the belt of Orion points vertically downwards to Sirius. Well, when Orion heads towards the western horizon, the belt is more or less horizontal. So Sirius and Orion's belt set more or less at the same time as Aldebaran in Taurus. This is the last, March is the last whole month to really enjoy the sights in Orion in a dark sky. By mid-April, it's starting to set during the evening twilight. Towards the southeast is Virgo with the bright star Spica, and in northern Virgo and stretching north from that is a region that is quaintly known as the realm of the galaxies. This is a region where there are two major superclusters of galaxies in Virgo and Coma. The brightest of these galaxies is around magnitude 10, so you're not going to see them in binoculars, but they're good telescopic targets if you want to try some astrophotography on them. We'll hear more about those in some future night sky notes. There are others in Leo, which is here coming into the south at this time, in the southern part of Leo, which I'll come back to. And of course, Gemini is still quite high in the sky above Orion in the southwest at this time. Looking east at our late evening time, 22 hours on March 16th, then the plough is high in the east. Remember that we can follow the handle of the plough round to Arcturus, arc to Arcturus, and then spike to Spica in Virgo. To the left of Arcturus, to the left of Butes, is the little coronet of Corona Borealis, the northern crown. Vega is in the northeast and starting to climb. One nice object to look for here is another galaxy, M51, which lies 3.5 degrees southwest of Alkaid. That's the end star of the plough's handle, an image taken by Pat Devine. The M51, this galaxy, is in Canis Venacity, the constellation of the hunting dogs, but it's quite close to Alkaid in Ursa Major. 31 million light years away, and is interacting gravitationally with this smaller galaxy, which is NGC 5195. M51 itself is around magnitude 8.4. So it's just in range of biggish binoculars in a dark sky. Let's take a look now earlier in the evening. This is March 16th, 1950, about 10 minutes, I think, after the end of nautical twilight. So the sky is pretty well dark. If you've got a dark background on your screen, you can possibly see the Milky Way here, shown by Stellarium, stretching from Cygnus in the north, through Cassiopeia, Perseus, Auriga, and on through towards Sirius. Mars is here. This month it's moving from near the Pleiades up to above Aldebaran. However, there's another globe besides the Milky Way, which I hope you can see here, which is the zodiacal light. This appears as a cone of light climbing up from the sun's position below the horizon, somewhere down here. When you see this phenomenon before sunrise, it's sometimes called the false dawn, but I don't often hear it talked about as the false dusk, but this is a false dusk, if you like. It extends as a cone of light reaching up from the sun. It's greatly exaggerated view, and it stretches along the ecliptic, the sun's path that I mentioned earlier, sun's path against the stars over the course of a year. Now, since all the planets orbit in more or less the same plane as the Earth, they always stay close to the ecliptic, and you'll see Mars is just doing that there. It's also where we might find many of the minor planets, asteroids. The moon also stays reasonably close to the ecliptic. The moon's orbit is tilted at 5 degrees to the orbit of the Earth around the sun. Now, during the spring, during March, April, the ecliptic is steep in the western sky, as you see, which means it's a good time to spot the inner planets Venus and Mercury, if they happen to be lying east of the sun, which they're not just now. But it's also a good time to spot the very young moon, and this is drawn from March 16. You see the moon is here, 15 degrees high. The previous night, it's only 5 degrees high, and it's down here, and that's the view on March the 15th. So if you look at early on March the 15th in the evening, you stand a chance of seeing a very, very slender moon, with the dark side of the moon lit by Earthshine, which is the light of the Earth, the almost full Earth in the moon's sky. On the 16th, on the day this chart is drawn for, that's the phase and appearance of the moon we can expect to see. As the moon moves up, it's moving towards Mars and the Pleiades. And if we concentrate on the motion of Mars this month, this is a plot of the motion of Mars from March the 1st to April the 10th. And you'll see that it's passing quite close to the Pleiades. And it's, in fact, it's closest to the Pleiades. It's due south of the Pleiades on the 3rd and closest on the 4th, which was yesterday, but only very slightly closer yesterday than it was on the 3rd. On the 16th of March, well, that's the appearance of Mars on that day, 5.8 arc seconds across. You'll be hard pressed to see much in the way of detail on Mars through a telescope now. It's got a bit too small for it to be easily imaged. During the course of the month, it fades from magnitude 0.9 to 1.3, so it's already a little bit fainter than Aldebaran, and it's getting fainter. It's about 70%. It drops by about 70% in brightness during the course of the month, because it's receding during this month. It recedes from 219 to 263 million kilometers. And on March the 19th, well, it's up here past the line between the Pleiades and Aldebaran, but it's also quite close to the moon. The moon passes 1/3 of the way between Mars and Aldebaran on the night of March the 16th. And that's the view of the moon on that occasion. This is a good opportunity. I hope some of our astrophotographers will try this out. Can we get a nice image showing that Mars, the moon, Aldebaran and the Hyades and the Pleiades all in the same shot? Challenge for you all. That's looking south in the early evening, 1950 on March the 16th. We're now seeing Orion relatively higher in the evening, in the southwest. It's belt pointing down to Sirius. Here's Mars near the Pleiades. Again, I've plotted the sun's future path through the sky, and in fact, come the solstice on June the 21st, the sun will lie there to the north of Orion. And that's 23.44 degrees north at its most northerly point in the year. That's June the 21st. But quite close to that, just there, is the star cluster M35 in Gemini, just visible to the naked eye if the moon's out of the way. Better to see through binoculars or a telescope. And that's a view by Horst of M35. It's an open cluster again, like the Hyades, like the Pleiades, an open star cluster. It's around 4,000, the stars in it are around 4,000 light years away and 175 million years old. This image also shows a much older cluster, NGC 2158, to the main cluster's lower right. That's much older. That's about 2 million years old, the stars there. It's much further away as well, 11,000 light years away. And I think it's probably too dim to see through binoculars, but obviously it shows up in images. I want to focus, though, on this region between Gemini and Leo. And that's it. It's centered on the constellation of Cancer, relatively dim constellation of Cancer. And right in the middle of Cancer is M44, yet another open star cluster. In fact, Mars, because it lies only 1 degree north of the ecliptic, this is the orange line, because it lies north of the ecliptic, it's often visited by planets and the moon. And in fact, come June the 23rd, Mars will pass right across plumb across the center of M44. By then, though, Mars is dipping into our evening twilight. We're losing sight of Mars by then in our evening twilight, but it's due for a date with Mars at the end of towards the end of June. Again, moonlight is enough to swamp it, but it is a naked eye object under dark sky conditions, and it's easy to spot through binoculars. Around 1,000 or more stars, 577 light years away, and the stars there formed around 600 million years ago, so they're about the same age. This cluster is about the same age as the Hyades. There's another cluster further south, which is interesting. Oh, that's a picture by Horst of the M44, which is also called Praesepe, or the Beehive star cluster. There's another cluster further south down here, M67, which is a tenth as bright as M44, and it's more distant, 2,600 to 2,900 light years. Now, it's also got it's also unusually old for a star cluster. Most star clusters, we think, break up in time. All stars begin their lives as in star clusters, but not all stars we see are obvious members of star clusters. This is a star cluster that's pretty old. It's thought to be between 3.2 and 5 billion years old. So it's one of the oldest star clusters that still is around. It has lots of stars also that are similar in age and size to the sun. And it's been even claimed by some people, though I think it seems unlikely, it's even claimed by some people that our sun formed in this star cluster and escaped billions of years ago. Well, as I say, it's unlikely. There is something else I want to mention in this area. It's an object you're not going to see unless you've got a huge telescope on a great site like Mauna Kea, and that's an object called Far, Far Out. And it lies there to the north of Cancer in the constellation of Lynx. Lynx spreads out over here. Lynx is a bit like Cancer. It's made up of relatively dim stars. In fact, it was only invented in 1687 by the Polish astronomer Johannes Hevelius, who declared that only lynx-eyed people would be able to see it because it's lacking in bright stars. Nevertheless, there's plenty of double stars, interesting variable stars, and galaxies in Lynx. Well, this is the position of Far, Far Out, the nickname for this object, on March the 16th. It's a magnitude 25.5, so you will need a giant telescope and great skill to sight it, which puts it more than 130 times further away from us than is the sun. It's at 19.7 billion kilometers away. And during the whole of March, it's moving only 8 arc minutes across the sky. It's actually heading westwards, and most of that motion is caused by the fact that our vantage point on the Earth is changing. The Far, Far Out is actually what we call retrograding. As an artist's impression of Far, Far Out, this was only really confirmed this last month. It's given the name of 2018 AG37, which indicates that it was the 932nd object to be discovered in the first half of January 2018. That's the rate at which they're discovering minor planets these days. It's thought to be about 400 kilometers across, and it's near the lower limit for being a dwarf planet. If it was much bigger, then we'd probably have to call it a dwarf planet because it would have been pulled into a relatively circular form by its own gravity. It was discovered by a telescope, the 8.2 meter Subaru telescope on Mauna Kea, by observers who were looking for remote solar system objects, including so-called Planet 9. They discovered an earlier record breaker, which was called Far Out, and so they had to do, this was, give it another nickname, this is Far, Far Out. Its orbit is something like this. It's only a guess, really, because many more years of study will be required before its orbit can be confirmed. It probably needs much more, many more observations before it can be named officially. It's thought it takes around 1,000 years to orbit the sun, and at its perihelion, it dips inside the orbit of Neptune at perihelion. Back to our general view in the south in the early evening in the middle of the month. The well-known asterism here, of course, is the winter triangle, formed by joining Betelgeuse, Procyon, and Sirius, more or less in the south as it gets dark. Right in the middle of the Winter Triangle is the constellation of Monoceros, the unicorn, which is another constellation that's poor in stars but rich in nebulae and star clusters. Several have been posted to our Flickr pages, including the Cone Nebula, the Christmas tree cluster, by Mark Phillips and our esteemed President Andrew with M50. I think Mark mentioned that one last month. The brightest star here, the brightest star in the Winter Triangle, in fact, the brightest star in the southern sky, the brightest star in our night sky, of course, is Sirius down here, which is 8.6 light years away, 1.7 times wider than the sun, 25 times more luminous. And it's got a white dwarf companion, which is magnitude 8.4, at about the same distance as Uranus from the sun. And that white dwarf takes 50 years to orbit Sirius. The white dwarf is similar in mass to the sun, but it's less than 1% as wide. And it's thought that at one time it was the much more massive star of the Sirius system. Anyway, I'll now focus on an area around Sirius, which we often overlook in our sky because it's so low down, and that's that area here. And there you see Sirius. 4 degrees south of Sirius is the star cluster M41 at a distance of 2,300 light years. I couldn't find an image of this in our society web pages, so someone should get busy and image M41 south of Sirius. Very easy to find. It's about as big as the moon through binoculars, around 100 stars, including several red giants. You can see them shining in this image. And it's about 190 million years old. 13 degrees to the left of Sirius, more or less in line with Mirzam, is up here, M46 and M47. I think Mark showed this again last week, a picture by Pat Devine. Again, these are fairly easy to spot through binoculars. They're 1.3 degrees apart, a bit less than 3 moon diameters, and they lie in the constellation of Puppis, the Poop Deck. Now, that was part of the constellation of Argo Navis until 1752. That was the alleged ship of Jason and the Argonauts. And 1752 was realized that was far too big to be a constellation. So they broke it up into Argo Navis. Argo Navis was broken up into Vela, the sails, and Carina, the hull, and Puppis, the poop deck. I'm not sure what a poop deck is, but that's what it is. Neither of the other two, Vela or Carina, are visible from our northern latitudes. Of these two stars, M47 is easier to see. It's 1,600 light years away, 78 million years old, so it's got a fair number of bluish hot stars. M46 over here is older, about 250 million years, so the hot blue stars have blown up or reached near the end of their life. And it's also further away. It's about 3 times further away at 5,000 light years. There is something else I want to pick out in this region because I haven't seen a picture of it in our Flickr group, and it's largely ignored, which is a bit surprising because it's only 5 degrees further south than M42, the Orion Nebula, and you can just see it on this Stellarium presentation, a glow here. It's called the Seagull Nebula, 8 degrees northeast of Sirius. It lies on the border, in fact, between Canis Major and Monoceros. I have found an ESO image of it. There it is, quite a nice, spectacular region. In fact, it's a complicated region of star formation, reflection nebulae, and emission nebulae. So again, maybe some of our photographers should do this. The densest bit here is the seagull's head, and these are the seagull's wings. There's also called IC2177. Now, I want to pick out a couple of stars here because I think they're interesting, and they are, although the southern one is is very low from Edinburgh. I did see it just a few nights ago. The first is Mearsam, which lies the brightest star to the, not brighter than Sirius, but a reasonably bright star to the right of Sirius, which is Mearsam is a hot blue giant star, magnitude 2, same brightness as the pole star. And it lies 490 light years or so away. It's 13 times the mass of our sun, 10 times as wide as our sun, and it's 26,600 times more luminous than our sun. But it's only about 12 million years old. Big stars die young, so it hasn't been burning all that long, and it's moving away from us at 34 kilometers a second. Now, when you play it back, 4 million years ago, Mearsam was only 37 light years away and would have been shining at magnitude minus 3.6, 7 times brighter than Sirius in our sky. So it's now receding and fading, but it was once brighter than anything. The other star of interest is further south in the constellation, and that's Adhara, which is actually the second brightest star in Canis Major. It's magnitude 1.5, so it's brighter even than Mearsam. Although Adhara is Epsilon Canis Majoris, and Epsilon is the 5th letter in the Greek alphabet. When they were assigned, when the brightest stars in constellations were assigned Greek letters, they were done in general in order alpha, beta, gamma, and so on, in order of brightness. But this was the 5th letter assigned by Johann Bayer in his Uranometria catalogue or atlas in 1603. So that's Epsilon. In fact, beta is Mearsam is beta. Well, Adhara is a bit similar to Mearsam. It's 430 light years away. It's similar to Mearsam in size and luminosity, and it's also receding. And 4.7 million years ago, it was only 34 light years away and shone at magnitude -4, in other words, about as bright as Venus in our night sky. Now, it's a fact that no other star has appeared as bright as this for more than 5 million years, and no other star will surpass it for another 5 million years. If we had eyes sensitive to UV, and if we were above the Earth's atmosphere, then Adhara would still be the brightest star in the whole sky because it emits so strongly in the UV. Okay, looking south, later in the evening now, Orion is heading off towards the west, and Leo is climbing up towards the meridian. Again, I plotted the ecliptic, which passes quite close to Regulus in Leo and quite close to the bright star Spica in Virgo. Now, I mentioned the zodiacal light earlier on, and I mentioned it appears as a cone in the western sky at nightfall at this time of the year. But in fact, the zodiacal light doesn't stop there. It stretches right around the sky following the ecliptic as a narrow, very dim band of light we call the zodiacal band. And just opposite the sun, it brightens again to form a oval region we call the Gegenschein, which is German for countershine. And this region always lies opposite the sun. But of course, if it's projected on in the region of the Milky Way or where there are many stars, you don't notice it. You can only really see it when it's projected against a relatively dark part of the sky. And I've seen it several times, never from Scotland. I've seen it several times, mainly from Mauna Kea, and mainly at this time of the year as an oval band, oval glow in the night sky in southern Leo and Virgo. And it's caused by backscattering of those dust particles in the zodiacal light. We're seeing all those dust particles full phase, and so they shine more brightly than they will while they're away from that position. The Gegenschein, of course, is moving. It moves in sympathy with the sun, so it moves around 30 degrees during the course of the month. Let's focus on Leo. This region is there. Now, the sickle is the most obvious part of Leo, a reversed question mark of stars with Regulus in the handle, or if it's a question mark, the dot of the question mark. Regulus, or Alpha Leonis, lies 79 light years away, magnitude 1.4, making it the 21st brightest star in our night sky. It's a blue-white subgiant, about 4 times wider and 4 times more massive than the Sun. It has a spectroscopic companion about 1/3 of the Sun's mass, and that's also, like the companion of Sirius, also probably a white dwarf star. So the history of Regulus may be similar to that of Sirius. It had a previously larger companion, which reached the end of its life, shed material, possibly loaded material onto Regulus, which is why Regulus is so bright now. There's another 8th magnitude companion to Regulus, 3 arc minutes northwest of Regulus, that's itself a double star with a separation of 2.5 arc seconds. So Regulus is actually 4 stars in total. It's a multiple star. But an interesting star north of Regulus is this one. So there's Regulus. Is this one, Algebra, which is a famous double star. It's also called Gamma Leonis, discovered by William Herschel. 2 stars, magnitude 2.3 and 3.5, separation of this year of 4.7 arc seconds. They're in a 400-year orbit around each other. And it's got a line of sight companion, which you can see below it, Forte Leonis, 1/3 of a degree south of Algebra, and magnitude 4.8. Now this plot from Stellarium also plots a number of red ovals, which are galaxies. And there are many more galaxies I've mentioned to the east of Leo in Virgo. I'm not going to mention go into detail about the Virgo galaxies for now. I'm going to concentrate on those in Leo, and I'm going to concentrate on this area to the south of Leo. This is the bottom side of the main figure of Leo, and these are all the galaxies I've put their names on. They're NGC and Messier numbers of the brighter galaxies named. They're in 2 main groups. The one over here is called the Leo triplet, and over here we have the Leo 1 group. The Leo triplet galaxies are around 35 million light years away, and they're visible through a small telescope. Magnitude 9 to 10, the 3 main galaxies, whereas the ones in the Leo 1 group are in general a little bit further away, 37 million light years away, and a bit fainter, magnitude 10 to 11. Ian Smith imaged the Leo triplet of late, but I couldn't find an image of the Leo 1 group taken by members. This comes from the Sloan Digital Sky survey of Leo 1. But anyway, these individual galaxies are all nice targets in their own right. So we do have some nice images of them individually on the Messier section of our website. There's another object on our Leo chart, which you may already have noticed, and that's the asteroid Vesta. Number 4, Vesta. This is the position on the 16th of March. It's called 4 Vesta because it was the 4th asteroid or minor planet to be discovered. And on this date, the March 16th Vesta is here. The motion of Vesta over the course of the month, in fact, to mid-April, is shown by that yellow line plotted by Stellarium. It's moving towards the northwest near this star Chertan in the body of the rear end of Leo. Chertan is magnitude 3.4, and it's a brighter star that lies between Regulus and Denebola, the tail star, the star at the tail of Leo. Vesta is easily bright enough to view through binoculars as it makes this pass. It reached opposition on March the 4th, yesterday, and tonight it's 1.2 degrees northeast of Chertan. So if it is clear, you go out with binoculars, then you'll have no difficulty in spotting it. It would be a naked eye object if you got a perfectly clear sky. Magnitude 5.8, it's 204 million kilometers away tonight. By the end of March, it's got to here, but it's faded to got to here 5.5 degrees northwest of Chertan. and by then it's faded a bit to magnitude 6.2. So it's an easy object to spot. If it is clear tonight and you've never seen an asteroid, go outside and you can't miss it. It's the brightest object in this region, above and to the right, to the left rather, of Chertown. That's the view of it from the Dawn spacecraft. NASA's Dawn spacecraft orbited the asteroid between July 2011 and September 2012. It's the brightest and second largest asteroid, which makes it a bit surprising. It was the fourth one to be discovered. It was discovered in 1802 by Heinrich Olbers, and it's this size, 573 kilometers at its widest, and it takes 3.63 years to orbit the Sun between Mars and Jupiter. And it's the only asteroid that we know of that's fully differentiated, in that it's got a core of a nickel iron core, then a layer of rock, and it's got a basaltic or a lava surface. And as such, it's probably a survivor from the very early days of our solar system, when the planets formed 4.6 billion years ago by lots of these protoplanets coming together. The other protoplanets that survived probably crashed together, and they're broken up, and they're what we see as the other asteroids. Still, it's amazing that Vesta has managed to survive. It contains around 9% of the mass of the entire asteroid belt. The only larger asteroid is Ceres, which was also visited by Dawn after it visited Vesta. Ceres has a diameter of 939 kilometers, and it's big enough, is Ceres, to be called a dwarf planet. And that Ceres was the first to be found in 1801, on January the 1st, in fact, 1801, the first year of the 19th century, found by Giuseppe Piazzi. And Ceres is the only one rounded by its own gravity, and it's the only, but it's also only partially differentiated, and probably has ice and rock throughout. Finally, tonight was one view of our eastern sky, or rather our southeastern sky before dawn. This is looking southeast at 5:48 on March the 16th, which is the beginning of civil twilight, when the brighter stars are disappearing into the twilight. This is only 37 minutes before sunrise, and 43 minutes after the end after the beginning of nautical twilight, which is, I always think of as the beginning of when nautical twilight, the end of nautical twilight in the evening is when it gets dark, and the beginning of nautical twilight in the morning is when it starts to get light. Saturn is down here, Jupiter is down here. Saturn is only magnitude 0.7, and it rose 29 minutes earlier than this. Jupiter rose only 9 minutes earlier than this. They're so low down that I think we can probably forget them for this month. And that is all I've got for you this time. Cheers.
Thank you very much, Alan. We can show our appreciation, please. Excellent.
Thanks very much.
And we'll be taking up having worked with Neil and the imaging group about all these holes that are in our catalogue.
Yes. Good.
Wednesday night.
Right. I'm going to stop sharing my screen now if I can. Stop sharing. Right.
Thanks, Alan.
Right.
Thank you very much. Unless anybody's got anything else they want to raise, I think that's reached the end of the evening's entertainments. So is there anything anybody wants to raise? Any questions for Alan?
Yes.